Okay. Thank you, sir. So I thought, let me start my presentation by showing the Jamovi software. Shall I change the slide now? Okay. Uh, Good evening to all my intellectual teacher friends and vibrant students. It is my humble duty to express my gratitude to Datta sir for giving me this wonderful opportunity, which I consider as a temple of learning. Before we start this session, let all of us thank Almighty for His countless blessings. Friends, we all know that there are many softwares to do statistical calculations. Like we have SPSS, Minitab, Jamovi, JASP, Smart PLS4, and so on. We also know that SPSS, Minitab are expensive. So many depend on open statistical softwares like Jamovi or JASP, etc. I frequently use either Jamovi or JASP because I felt that these two softwares are user friendly. To support my view, let me show Jamovi software and how it works. Can you see this software? Somebody respond. Can you see this software?
Yes, ma'am.
Thank you. Now, first, how to import the data into the software? You can see here 4 lines. If you click on that, you can see import option. If you click on that, you get this portion where it is written at the top browse. If you click on that, you get the documents what you have loaded either in Excel or Word format, anything. So if you click on that, it gets imported into the data. If you click on to that, the data got imported in my case just now. It gets imported. So how to import? 4 lines. Import, browse, and whatever the data you want to upload, click on that. Automatically, it gets imported into the software. That is first part. Second part, here you have exploration. If you click on that, you can see descriptive. Descriptives means what? All descriptive calculation, statistical calculations can be done by using this particular tab. If you want to use t-test, here you can see the t-test tab. Then if you want to do ANOVA, you should click on this. If you want to do regression analysis, here you can see the tab. If you want to do reliability test, here factor analysis, this tab. This is what is that? Median mediation analysis or moderation analysis. You can use this tab. Okay. Now, for example, I take the first one. Click on descriptives, and I want to calculate. Let us assume I want to calculate frequencies. If you click on descriptives, you can see this portion. There, two windows. Here, the data what I uploaded, you can see. Here, I have to transfer the data, the required data. If I transfer, this side you get the output. Okay. Now, I want to calculate frequency table. Activate that. Okay. Now, uh, transfer the data into the box. So I will do that. AB. If I transfer, see, we got it. The percentage, we got it. Yes, no percentage, we got it. If I want to know some more details about the percentage, uh, transfer. This we are not getting the values because I'm using categorical data. Okay. Before that, see, you can see two circles and A. That indicates this symbol will have categorical data, qualitative data, like male, female, satisfied, not satisfied. Such type of data will be loaded into this kind of symbol. Here you can see a rectangle box. It contains continuous data. Here you can see three circles in triangle shape. It will have rating scale. If I opt Likkert's rating scale, 5-point scale or 6-point scale, that rating scale details will be uploaded here. Now I want to calculate frequencies. For calculating frequencies, I should use categorical data or qualitative data. So one I transferred here, the other one I transferred, I kept under split by, and this is how I got the table. Female and male, how many said yes, how many said no with regard to placements. That is happening in the colleges. So you get the table like this, right click you and copy it and put it in the Word and write the interpretation. This is one part of the story. The second story is I want descriptive statistics. Then click on the statistics. So you get several options here. Whatever the descriptive statistics I need, if you activate that, you get the values. So n, the number of respondents you get. I don't want missing value, so remove it. I want mean. I don't need median, remove it. Standard deviation I want. Minimum maximum value I want, activate that. I need skewness. I need kurtosis. Click on that. And we are not getting the values because I'm using I kept here categorical data. So it will not give value. Now I will transfer the continuous data. Say I got it. So mean I got, standard deviation. The minimum value is 1.33. 1 is the minimum point. The maximum is 7. That means here the author is using 7-point scale. And I have skewness values, I have kurtosis values, etc. Now, what does what does each statistical tool convey here? In case of mean, higher the mean, the better the model. In case of mean, higher the value, better will be the model. In case of standard deviation, the value should be less than 1.25. This is minimum and maximum, the scale what I've adopted, the details it is showing. Skewness, it should be between -3 to +3. It should be between that. Kurtosis, it should be between -10 to, -30 to -10 to +10. Okay, this is descriptive statistics. If you do the right click, you can copy it and put it in the Word. Okay, this is second aspect. See, if you put it like this and click on this, all the variables what I transferred here goes back to its original place. Okay, the next one, uh, let me show you how that exploratory factor analysis is done. See, here I have exploratory factor analysis. Now, what is that? It is a technique used to reduce huge data into few meaningful factors. Reducing the huge items into few meaningful factors. That is the strength or unique feature of EFA, exploratory factor analysis. So, let me transfer the data. I am transferring the data relating to individual items or questions. Okay. So here we got the data. Now we have to analyze it. See, H1, H1, H2, H3 means HR practices. R means recruitment and selection. See, the first factor includes human resources practice and recruitment and selection. That is not possible. Under HR practices, you cannot add recruitment and selection item. You cannot add. Okay, there is no relationship between the two. All HR practices should be formed as one group. All recruitment and selection should be formed as another group. But here it has not happened. HR practices and recruitment selection is mixed. Here also you can see the mixture of R and T. T stands for training and development. Here also you can see the mixture of uh, promotion and work environment, mixture of too many items. This is not a accurate table which can be carried forward for further analysis. So what to do? Wherever you find weak items, it should be removed from the list in order to get uh, a proper grouping of items under one head. So how to do? The theory says the factor loading value should be more than 0.40. But here I have one minus 0.351. Remove it. Sorry, H2 should be removed. Here I can see H2. Remove it off. So we'll get different values here. So we got different values, but still there is a mixture. So what you do? Here W2, I have the value which is less than 4.0. So remove it. W2, let us remove it. If I remove that, okay, I got the values like this. Still there is a mixture. So let me remove R1. It is mixed with HR planning. So I will remove R1. So HR practices formed as one group. R2, R3 is mixed with training and development. Again, if you remove it, you should go on playing with the data like this till you get a proper formation. Okay. Here, we could not get proper formation because I did not do one more test, that is correlation test. Directly, I took the variables and did factor loading calculation. First, we should do correlation and find out whether there is relationship, and then do factor loading. So here I did factor loading directly, so we are not getting proper groups here. Uh, I showed this just to convey to you that exploratory factor analysis, when we are doing, we need to play with the data. Certain weak items, if you remove it from the list, you get proper groups. With the help of those groups, you can use any kind of advanced statistical tools for further hypothesis testing. So this is how the JAMOB works. Very easy compared to SPSS. Okay. Now I will go back to my PPT. I will close this. Yeah. Can you can you see the slide PPT now?
Yes, madam.
Okay. Now somebody has sent the message. Uh, which type of software I'm using? What I showed to you uh, is Jamovi software, open source. You can just download from the website and use it. JASP also open source, and you have one more to do SEM analysis, that is PLS Smart PLS4. All these are open source softwares. Just download it and use it, for which you need not pay anything. If you want to do the same calculation in SPS, you need to spend some money. Okay, the decision is left to you. Now, let me come to the point. Uh, Today, let us discuss the aspects like factor analysis, sample composition, descriptive statistics, chi-square, t-test, and ANOVA in this session. The remaining, like correlation analysis, regression analysis, mediation and moderation analysis, and finally, SEM analysis tomorrow. So, this is my plan for this workshop. Now, in this session, as you all know, we are mainly focusing on how to choose appropriate statistical tools for data analysis. We all know that we need to consider four criteria for selecting appropriate statistical tool. The first one is purpose of the study. Let me explain this point with an example. Suppose if I want to measure the relationship between two variables, I use Carl Pearson's correlation analysis. Or if I want to measure the impact of independent variable On dependent variable, I use regression analysis. Okay, this is one criteria. The second one, um, the second criteria is the number of variables used in the study. For instance, if I use only independent variable in my study, I may opt one sample t test or z test. Or if I use three variables like independent variable, dependent variable, mediating variable, then I will be doing mediation analysis. Friends, before we take up the next criteria for discussion, I thought, let me explain the meaning of concept, construct, variables, dimensions, factors, items which we find in the research articles. For instance, yes,
Ma'am, you said one sample t-test you will use.
it,
What would be the combination for usage of one sample t-test?
one sample t test, only example I gave, it is done only in, what is that? Quality assurance department where they have to do quality check. They do this. In social science research, we never use this tool at all. Paired sample or independent sample t test only we do. Okay. For instance, if my specialized area of interest is uh, human resource management, then HR should be considered as concept. If I use the same concept in my study, it becomes construct. If values are assigned to such constructs, it becomes variable. For example, if my research topic is impact of HRP on business performance, then HRP, that is human resource practice and business performance, should be considered as constructs. As these constructs are measurable, they can be coined as variables. Now, to measure HRP, I should identify factors. The other name for factors is dimensions. For instance, to measure HRP, I may identify factors like training and development, performance appraisal, recruitment selection, and so on. For each dimension, I may include 4 to 5 questions. These questions will be called as items or statements. This is the meaning of concept, construct, variable, dimension, and items. Okay. So when we read the article, sometimes the authors may use interchangeably. To avoid that, I shared the meaning of these words. Okay, let us move to the next one. The third criteria to be considered is use of scales of measurement. That is, if I have categorical data, or the other name for categorical data is data in the form of yes no type, like number of people infected or uninfected by corona in 2019. I have such kind of data. Or number of people married or unmarried in Bangalore city. For such kind of data, we use nominal scale. The next one is, if I have categorical data in the form of ranking, then I should use ordinal scale. Again, if I have continuous data relating to attitude or perception, wherein the lower limit of first class is not zero, I should use interval scale. On the other hand, if I have continuous data relating to cost or sales or age, wherein the lower limit of the first class is zero, I should use ratio scale. This is about the scales of measurement. Now, the fourth criteria which should be taken into account for deciding which statistical tool to be used is whether the data is normally distributed or not. For instance, if my data is normally distributed, I should use parametric test. On the other hand, if my data is non-normal, not normal, then non-parametric test should be used. Now, let us spend some time to know the difference between parametric and non-parametric test. The first one, parametric test uses variables, whereas non-parametric test uh, uses
So, ma'am,
attributes. Yes,
ma'am, I have one doubt.
yes.
Please tell me the example for the normal distribution and skewed distribution.
Yeah, normal distribution, when you plot the data, what you have on the graph, you get bell-shaped distribution. You are seeing on the slide. If it is skewed, either it will be skewed towards the right or to the left. In simple words to say, instead of telling the mean, how to what extent the mean is away from median and mode, I'm presenting in this way. Okay,
Okay.
bell shaped. If you get it is a normal distribution. If you don't get bell shaped curve, it becomes a skewed distribution. Okay. Uh, Parametric test uses variables, whereas non-parametric test uses attributes. We all know that variable will have quantitative data and attribute will have qualitative data like yes no type of data. Now, what do you mean by yes no type of data? Just now I gave example, how many married, how many not married. Okay, uh, that is called attribute. In case of parametric test, assumption check is done. That is, whether the data has equal variance or not, or whether the data is normally distributed or not, we do this kind of check. In case of non-parametric test, such assumption checks are not done. Parametric test uses interval scale, whereas non-parametric test uses nominal scale. In case of parametric test, statistical tools like Carl Pearson correlation, uh, that is one, t-test, z-test, ANOVA is used. In case of non-parametric test, Spearman correlation, Kruskal-Wallis test, Mann-Whitney test is used. These are the difference you find between parametric and non-parametric. But what mainly the point to be considered is whether the distribution is normal or skewed. If it is normal, you are going to use parametric test. If it is skewed, non-parametric test. Okay. Coming to exploratory factor analysis, the point to be noted is if the researcher has developed the questionnaire, then he is required to do both exploratory factor analysis and confirmatory factor analysis. On the other hand, if the student is using developed questionnaire, then he is required to use only confirmatory factor analysis. Okay, if I am using developed scale, do only confirmatory factor analysis. If I have developed the scale, I need to do both exploratory and confirmatory factor analysis. Now, the question is, what is exploratory factor analysis? Uh, we all know, most of us know what it is. Anyway, let me tell. EFA is a data reduction and data summarization technique. In other words, EFA is nothing but bringing down huge number of items into few factors. EFA can be employed if researchers do not get theoretical backup relating to his study area. Only then EFA we need to do. For instance, if the researcher has decided to do research on the topic organizational sensitivity, he has to undertake EFA because he will not get sufficient theory relating to organizational sensitivity. Then one more point to be kept in mind is EFA can be used if scale is not constructed or developed relating to his study area. If I want to do EFA, I need to consider certain points like we should use interval or ratio scale and we should have too many questions. And to do EFA, first we should calculate correlation matrix. First thing. Then convert the items into factors by using eigenvalues or parallel analysis. All these options you find in the software, just click on that. You get the values. Then use maximum likelihood method to estimate the values. There is one more method that is principal access factor. But maximum likelihood gives better results. Then use Varimax or Oblimin to do factor loading rotation. Now the question is when to use Varimax or when to use Oblimin. Now experts say based on theory, if you find that there is a relationship among the items, use Oblimin, or based on theory, if you find that there is no much relationship, use Varimax. If you reverse, you will not get good results. Again, the sample size should be 1:10 for doing EFA. That is, for one question, there should be 10 respondents. That means the total number of respondents will be 1 into 10, that is 10. If the number of questions included in the study is 20, then the total number of respondents will be 10 into 20, that is 200. This is the sample size we keep in mind to do the EFA calculation. As mentioned earlier, the first table to be prepared under EFA is intercorrelation matrix. In this case, we should observe the pattern of R values. If all R values are more than 0.70, all or all R values are less than 0.20, we should doubt the data. Definitely, for such kind of data, EFA cannot be done. Even if you do it, EFA will not give better results. So, utmost care should be taken to see that all R values are between 0.30 to 0.70. Then, one more point to be noted in this case is, for doing correlation analysis, there is no need to identify which is independent variable and which is dependent variable, not required. So this is about intercorrelation matrix, the points to be kept in mind. We'll move to the next slide. The second table which comes in exploratory factor analysis is KMO. The author name is mentioned there. So KMO, measure of sampling adequacy. Here, what we should observe is the overall value should be more than 0.50. In this case, that is the table what you are seeing on the slide, the overall value is 0.897, which indicates that the sample size what the researcher has taken is adequate. So to find out whether sample is adequate or not, we have to do this calculation. And next one, the third table in EFA is preparing a table to show the results of Bartlett test. This should be done to see whether there is any relationship among the items. Now the question is how to find out. Friends, just observe p-value. If it is less than 0.05, then there is relationship among the items. In this case, the data what I am showing on the slide, the p-value is less than 0.001. That means there is relationship among items. This is about the third table which comes under EFA. The next one. In fourth table, we should show factor loading. The values should be more than 0.40. In this case, we come across one more aspect, that is uniqueness, which means the item-wise error, and that uniqueness value should be less than 0.50. In other words, lesser the error, better the model. That's all you're going to observe here. The next one. Here, the sum of squared loadings should be more than 1. Now, in this table, it is more than 1, that is 3.61. So, this data can be taken for further analysis. According to Harman's rule, percentage of variance of the first factor should not exceed 25% to avoid common method bias. The percentage of variance of the first factor only you should observe. It should not exceed 25%. Now the question is, what is common method bias? So from my side, the answer will be, if we take feedback for both independent variable and dependent variable from the same person, bias may arise. For example, if my independent variable is organizational culture and dependent variable is employee performance, and for both these variables I take feedback from the same employee. So in this case, what may happen? He may give true feedback for organizational culture and wrong feedback for employee performance, that is his own performance. So how to avoid such problem? We have two options. One is take feedback from different persons, or do factor analysis, and if percentage of variance of the first factor exceeds 25%, then what you do? Remove the weak items from the list. Keep on doing this till we get percentage of variance of the first factor which is less than 25%. This is the second option, which is not possible to do it. Only the first option will be the better one. Take feedback from different source. Don't take feedback from the same source to avoid common method bias. Okay. The next one. Here you find eigenvalues and it should be shown in the report, and this value should be more than 1. If it is less than 1, such data cannot be taken for further analysis. And even the examiner will reject the report if eigenvalues are less than 1. Okay? Then the next one. After all these calculations, we should write a report on exploratory factor analysis. How to write? Here is the example. I am reading from the slide. So the first point is, EFA was performed to extract factors from 18 statements, that is questions, that were used in the study by using maximum likelihood estimate method and Oblimin rotation. The second point is, the EFA has generated 4 factors based on parallel analysis. The solution in toto explains 24.1% variance. This is to justify that their data does not suffer from common method bias. The third one, out of 18 statements, one statement, that is H2, got less than 0.40 factor loading. Therefore, H2 statement was deleted from the list. The KMO measure is 0.897. This means that the sample size is adequate to perform EFA. These are the 4 points you're going to write it after doing so much of calculation. This is about EFA. Now, we come across one more data reduction technique, that is principal uh, component analysis, or we call it as PCA. Here, though the purpose of PCA is same as EFA, we find a difference between PCA and EFA. Now, what is the difference? Let us discuss now. If I am using formative model, PCA should be used. On the other hand, if I am using reflective model, EFA should be used. Now the question is, what is formative model and what is reflective model? Let me explain with example. In case of formative model, what I do, I identify the items first. I identify the questions or items first. And based on those items, I try to define the construct. For instance, let us assume the items identified by me are caste and income. So, based on these, we can define construct as socio-economic status. If I remove one item, the meaning of the construct will change. That is, if I remove income, then my construct becomes socio status but not socio-economic status. That is the speciality of formative model. Okay. So in formative model, we identify the items first. Based on the items, we try to define the construct. Now, let us discuss reflective model. In this case, we define construct first, and based on that definition, we identify the items. Even if we remove one item, the meaning of the construct will not change totally. For example, I have taken job satisfaction as construct, and to measure this construct, I have taken two items. That is, I like the job, I am happy with the work environment, and so on. Even if I remove one item, the meaning of job satisfaction will not change totally. This is the unique feature of reflective model. So in reflective model, we define construct first. Based on that definition, you try to identify the items. So if you are using formative model, go for PCA. PCA. If you are using reflective model, go for EFA. That is what I want to convey. Now, the next analysis is confirmatory factor analysis. Now, as mentioned earlier, if I have developed the questionnaire based on review of literature, I should do both EFA and CFA. If I am using already developed questionnaire, I need to do only CFA. Okay. Now, what is the CFA? The distinctive feature of CFA is that the factors come from theory and not from statistical results like EFA. CFA can be used if the researcher has prior knowledge about grouping of various items into factors. Then the CFA can be used if standard scale is available. Otherwise, we have to do EFA and then come to CFA. Now, in CFA, the first table we need to show is convergent validity test table. It will be the first table in CFA. In this table, we should carefully observe standard estimates, composite reliability, and average variance extracted. According to Fornell and Larker, standard estimate values should be more than 0.70. Then composite reliability values should be more than 0.80. Average variance extracted values should be more than 0.50. Only then convergent validity test is said to be fulfilled. So this we have to keep in mind. The second table in EFA is discriminant validity test. In this table, you can see few values put in red color. They are obtained by finding square root of average variance extracted. Average variance, square root you find out, those values are highlighted here. The remaining are correlation values. According to Fornell and Larker, the the square root of average variance extracted values, that is AVE values, should be more than correlation values. But in the table you can see the square root of AV value is more than the correlation values, what is put in black color in each column. It is more. So we can say that the discriminant validity test is fulfilled. That is the thing we need to do with regard to this test. Then the third table is related to goodness of fit index. Here we have to show fitness index with specified criteria. For instance, in case of first one, chi-square, we should compute chi-square, then divide it by degrees of freedom. After dividing, whatever the value we get, that value should be less than 3. This is one specified criteria. The second one, in case of root mean square error of approximation, in other words, we call it as RMSEA, RMC, RMSEA. The computed value should be less than 0.08. In case of normed fit index, the value should exceed 0.90. In case of standard root mean square, the computed value should be less than 0.08. In case of goodness of fit index, the value should be more than 0.90. In case of comparative fit index, the computed value should be more than 0.90. in case of Tucker-Lewis index, the computed value should be more than 0.90. So this slide shows only uh, the specified threshold limits. We'll move to the next one. This table is taken from one of the published article in order to give clear picture to you regarding how to present the model fit index in the report, and also how to write interpretation. So how the values are presented, I think it is clear to you. Now I will move to the interpretation part. How to write, I just read. As the fit index computed values meet specified requirements, the model developed by the researcher is fit to be good. Therefore, the model is used for testing proposed hypothesis. That's all. Okay, we'll move to the next one. The next table which comes under CFA is a very important table. Cronbach alpha reliability test. In this table, we should observe two aspects. One is alpha value, which should be more than 0.70 most of the time. And item rest correlation values should be more than 0.30. The one more point to be noted is if you use standard scale, that is already developed scale, the alpha value should be more than 0.70. If you develop the scale and even if the alpha value is 0.60, it is acceptable. And in this case, how we are going to write the interpretation? I just read from the slide. In this study, researcher used Cronbach alpha to measure reliability of statements. The Cronbach alpha values for the constructs exceed the recommended value of 0.70, which demonstrates that the instrument is reliable. That's all. This is how you're going to write the report. Okay, we'll move to the next one. Uh, this is the last table which comes under CFA. The title of the table will be collinearity test. Here we should observe that the variance inflation factor should not exceed 5. Tolerance value should not exceed 1. Condition index is not more than 10. If these requirements are fulfilled, then there will be no collinearity threat. Now the question is, what is collinearity? The answer is, if two or more independent variables are highly correlated, it becomes difficult for us to find which independent variable is contributing more towards dependent variable. To avoid that, we need to do this test. The next one. This is sample composition. What most of the experts says, in every thesis or article, the details of sample composition should be shown. In other words, or to be more specific, irrespective of your objective of study, sample details should be presented and it is mandatory. The point to be noted in this case is the details can be shown either in the form of graph or table or text. But combination of all the three is not required. Any one format you can select to present your sample composition details. Uh, Here you can see the sample composition details presented in one of the published article. They have just given the table, no explanation, no graph. So you present either in the form of table, or you choose to present in the form of graph, or put it in the form of text. Okay. The next one, in the next table, that is the slide what you are seeing, we have to give the details of descriptive statistics. Now the question is why? Experts say that without descriptive statistics, we cannot know the distribution of data. So we have to give the details of descriptive statistics irrespective of the objective of the study. Okay. Here, uh, the statistical tools like mean value, standard deviation value, minimum and maximum scale, skewness, kurtosis can be highlighted. And I mentioned already, in case of mean, higher the value, better will be the model. In case of standard deviation, the value should be less than 1.25. Or, in other words, lesser the value, better the model. In case of skewness, the value should be between -3 to +3. In case of kurtosis, the value should be between -10 to +10. This is about descriptive statistics. Now, the next one. So, in this slide, you can see the details of descriptive statistics presented in one of the article. Okay. Uh, I will move to the next one. Now, we are going to spend more time on this topic, that is, use of appropriate statistical tools. Now, let us assume I have two attributes, X attribute and Y attribute. X attribute contains gender, that is male female details. Y attribute contains details of the placement, that is placement happened or not happened, and the distribution is non-normal. Then what is the type of statistical tool you're going to use to test the hypothesis? It is chi-square. X also categorical, Y also categorical, and the distribution is non-normal. We should use chi-square non-parametric test only. If I use chi-square, how to formulate hypothesis? So I just read from the slide. Null hypothesis, there is no association between male and female students with regard to placements in respondent institutions. There is no association. Okay. Alternative hypothesis, there is association between male and female students with regard to placements in respondent institutions. This is how the hypothesis should be formulated. Here you find the table showing chi-square value with male and female details for placements. So, what you should observe is observe highest percentage which is given in the table. In case of male, it is 62. In case of female, it is 42. Underline that. After that, observe p value. Okay. Then it becomes easy for us to write the interpretation. Okay. So, how to write the interpretation? Uh, Before explaining that, let me tell you one thing. That is, you all know, I think, if p value is less than 0.05, null hypothesis is rejected. If p value is more than 0.05, null hypothesis accepted. So, taking this as the base, we have to decide whether the hypothesis is accepted or not. Here, what is the p value? 0.045. It is less than uh, 0.05. It is less than that. So, null hypothesis is rejected and alternative hypothesis is accepted. Now, if the alternative hypothesis accepted means what? There is association between male and female students with regard to placements. That is the meaning we get. So, in case of chi-square table, how we are going to write the interpretation? Let me read from the slide. It is evident from the findings that 63% of male students secured job through campus recruitment compared to 57% of female students. On the other hand, 43% of female students did not secure job through campus recruitment compared to 37% of male students. The chi-square value is it is different here, 0.5 something. One is degrees of freedom, and the it is correct. The chi-square value is 0.533. One is degrees of freedom. P value is 0.045, which is less than 0.05. Therefore, the null hypothesis is rejected. Now, what is that null hypothesis? There is no association between male and female students with regard to placements in respondent institution. And alternate hypothesis is accepted. This is how we are going to present the report in case of chi-square test. We'll move to the next one.
Yeah, just a minute, ma'am.
Ah,
Uh, in the previous slide, just
go back
yeah.
1 minute. This one,
No, no, no. Just now you explain, no, ma'am, the p value and 0.533, the reporting part.
Reporting part. Okay.
Yeah. Ma'am, the chi-square which shows the p value is 0.045, which has three values, three decimal values. Whereas here we find only two decimal values, 0.05, which is 5%. So,
0.050.
okay.
Shall I move?
Yeah. Thank you.
In case of chi-square, we come across two types of chi-squares. One chi-square test is used to measure the association between two attributes. Another chi-square is used as a test of goodness of fit. We already discussed in CFA, chi-square divided by degrees of freedom, the obtained value should be less than 3. That one. So, we have two types of chi-squares. One is used to measure the association. The other one is used to measure the goodness of fit in the model. Okay, let me take up the first one to measure the association between the two attributes. Now, what are the requirements? We should have two categorical attributes. Uh, then, how we are going to formulate the hypothesis here? Null hypothesis, there is no association. Alternate hypothesis, there is association. And the remark is higher the chi-square value, better will be the outcome. And the p-value should be less than 0.05. These are the requirements for this particular type of chi-square. Chi-square used for measuring the association between two attributes. These are the requirements we should keep in mind. Okay. In case of goodness of fit, we can take any number of variables. The data should be continuous, and hypothesis, null hypothesis, you're going to take like this: model fits the data. Alternate hypothesis, model does not fit the data. And the remark is lesser here, lesser the chi-square value, better will be the model. And the p-value should be more than 0.05.
Okay, ma'am. You
Okay.
have told about continuous data, no, ma'am.
Yes.
How to utilize this continuous data in the questionnaire? Because continuous data is height like that we are utilizing, no?
Likert
In a
scale.
Likert scale data for social sciences, how do you make a continuous data?
Likert scale is continuous data.
Okay. That
Hmm.
is 1, 2, 3, 4, 5. The values assigned is a continuous one. You say about that?
Continuous interval, yeah. 0 to 10, 10 to 20, 20 to 30. Okay. I clarified your doubt.
Yeah.
Excuse
Categorical
me.
data and continuous data. Continuous, you don't do fractions.
Excuse me, ma'am.
Huh.
Ma'am, I have two doubts, ma'am.
Yes.
We need to apply the statistical, that is, we need to apply the test for all the questions in the questionnaire, or depending on the relations or dependency or
No, all the tests not required. You see the data, ma, what kind of data you have.
huh.
If I have categorical data, X also two types of data I have. One is gender, the other one is placement. I took the example.
No, ma'am.
Both are
I'm asking if I have a 60 questions in the questionnaire,
Ah.
I need to apply the statistical for all the 60 questions or not?
No, you divide that into three parts. No, first
Yeah.
demographic one part,
Okay.
then second part the constructs, the theoretical constructs.
Okay.
You'll have four or five constructs,
Okay.
and each constructs based on the nature of the data, you should decide
Okay.
whether you're going to use it chi-square or t-test or ANOVA
Okay.
and so on.
And ma'am, it is good to have a measurement scale, or we need to prepare. We can develop the questionnaire.
Develop the questionnaire, fine,
Okay.
but in most of the PhD Viva examinations,
Okay.
the examiner recommends to use developed scale.
Because my topic is influence of leadership style, motivation, and work culture and employee performance.
Mm.
I developed a questionnaire on the basis of hypothesis and objectives.
Okay, fine.
Is it
Then you need to do EFA and CFA both.
okay? Yeah, yeah. In the inception, you only told now, ma'am.
Ah,
Yeah. Okay, ma'am. Thank you.
okay. Shall I move to the next one?
Yeah, ma'am.
Yeah. Next is t-test. Here I have two variables, x variable and y variable. X is a categorical variable and y is a continuous data. X is categorical, y is continuous. And I have two study groups. I have taken two groups in my study, and here I have taken, for example, male, female, two groups. So I repeat again, when to use t-test. X is categorical. X only should be categorical. Y cannot become categorical. X should be categorical. Y should be continuous. And I should have two study groups in my research work. And the distribution is normal. If all these requirements are fulfilled, I can use t-test. So X is categorical, Y is continuous. For categorical, I have taken the example of gender. For continuous data, I have taken the example of job satisfaction. On Likert scale, I am going to take the feedback. The distribution is normal, I am assuming. Then t-test parametric test should be applied. If I use t-test, how to formulate the hypothesis? You can see on the slide, null hypothesis. There is no significant difference. 1 minute, I'm deviating. See, only Indian examiner is expecting I should use the word significant in the hypothesis. Okay, foreigners say don't use it. Foreign examiners insist that the word significant should not be used in hypothesis formulation. After testing, after obtaining the results, whether the difference is significant or not, you're going to tell, but not in the beginning when you formulate the hypothesis. Okay. Anyway, our people are insisting, so we shall use it. Null hypothesis. How you're going to
Excuse me, madam. I'm Professor Parameshwar Iyer, retired faculty from Management Studies, Indian Institute of Science.
yes, sir.
I'm attending this workshop MDP of yours, which is a very useful and interesting one. I appreciate the excellent presentation you're making. I just
Thank
had
you.
a couple of suggestions. You know, we need to split the theory part of statistics from the application and case study part of it. So, if since you're doing two-day program, my suggestion would be for similar programs in future, first do a basic theory concepts. What are the things to be done in a research project? How do we select a problem? How do we do a research review of literature? How do we formulate the questions to be asked? Do we need to develop a questionnaire ourselves, or can we use some standard models and tools? And then how do we collect data? And then you from there you go into the statistical analysis of the data to say how we can analyze what are the different tools, what tool can be used where. So that theory part you can cover in one lecture. And the second lecture, my humble suggestion is do a case study. Pick up an actual research problem that you have worked on and go through all these processes with respect to that particular problem, highlighting how you answered each of these questions at each of these steps, so that the participants will get a very clear understanding, the theory part and the case study. For
Yes.
instance, I wrote a book on engineering project management, and I split the book into two parts. The first part was on the basic concepts of engineering project management, so called theory part of it. And the second concept had 7 case studies, which people can then relate the theory to the case study. So these are examples we carry through all the theory concepts given in the first part, and then illustrate each one of them with the a particular case that we are looking at. So this is my suggestion. I don't know how you react to it, but thank you, and I'm sorry I am interrupting you during your
Yes, sir. Very good
presentation with
suggestion.
these suggestions. Yes,
Yeah.
madam.
Thank you for the valid suggestion, sir. I think uh, we can take your suggestion seriously. But here, what happened? I started from the topic data analysis.
Okay.
What happens before data analysis? I'm not bothered.
Yeah, but in a real research problem,
I know, I
that's
know.
where we have to focus most of our attention on.
I know, I know. Yes, sir.
If somebody
Definitely.
gives me data, I can put it through so many software tools which are available, which will do all the analysis and give me the
Yes, sir.
results, even print out the uh, tables, print out the graphs, print out everything. I just need to add a few paragraphs of comments, and a thesis is ready. This is how many of my former students, I have guided over a dozen PhD students at Indians of Science. Many of them would tend to do it that way, but I would tell them with due respect that that's not the way to do research. If it's a research development program, we need to tell them how do they first pick a problem, how do they
Yes,
analyze a problem, how do they review the literature, how do they formulate their model to analyze, what are the questions they will ask, how do they make a questionnaire, and once the data comes from the questionnaire, actually the rest of it is relatively mechanical. I'm not devaluing or degrading data analysis, but too much hype is made of that today, and everybody wants to do analytics, everybody wants to do machine learning, everybody wants to do
sir.
artificial intelligence. But in that process, they have lost the natural intelligence that they had. So this is just a comment I wanted to make. Sorry, I'm interrupting you
Now,
in your.
Chat GPT has come where it can do review of literature. It can give us research questions.
Yeah.
Yeah, we need to learn all those by.
Actually, I'm proposing to Professor Bolanath Datta, who is the president of MTC and chairman of the Knowledge Management Center. I'm proposing to him that I will conduct similar workshops in a few topics where I'll illustrate what I'm talking about today, the
Yes, sir,
theory part
definitely,
and the case study part. Thank
definitely.
you so much for your attention and sorry
Yes,
for
sir, yes, sir.
interrupting your talk.
Thank you for the valid suggestion. Definitely, I take this seriously, sir.
Thank you, madam. Thank you.
Okay. Shall I move on, sir?
Please, please do.
Okay. Now, T test when to use, I explained. Uh, X should be categorical, Y should be continuous, the distribution should be normal distribution. Only then we can use T test. If you are using T test, how to formulate the hypothesis? Null hypothesis, you can write like this: there is no significant difference between male and female employees with regard to job satisfaction. No difference. Alternative hypothesis: there is significant difference between male and female employees with regard to job satisfaction. Okay. Uh, on the other hand, the another aspect here is X is categorical, Y is continuous, but the distribution is non-normal. Then you're going to use Mann-Whitney non-parametric test. Instead of t-test, you're going to use Mann-Whitney non-parametric test. Okay. That is about t-test. In case of this is how the t-test table will be. Uh, Before analyzing the t-test table, we need to do normality check or Shapiro-Wilk test. It is nothing but checking the normality. To do that, we need to take hypothesis like this: HO, data is normally distributed. H1, data is non-normal. If it is accepted, the HO should be accepted. Only then you can proceed with t-test calculation. Let us assume it is accepted. Then what you should look into in case of t-test table, first see the mean value: 5.81, 5.57, male, female. The next, directly see the mean difference. Then see the p-value. Okay, here the p-value is uh, 0.06. It is more than 0.05. That means the null hypothesis is accepted. And how you are going to write the report? It is not there. Uh, Let me tell orally. You are going to tell, first tell the mean percentage of male is how much and female is how much. Then talk about the mean difference. The null hypothesis is accepted. And what is that null hypothesis? You write that. Or some 3 lines matter. Now comes ANOVA. Now, what is this? X and Y. I have two variables, but X is categorical in nature. Y is continuous. The distribution is normal. And I have 3 study groups. More than 2, if you have study groups, then go for ANOVA. If you have only 2 study groups, t-test. More than 2 study groups, go for ANOVA. That is the difference you find between t-test and ANOVA. So here I have taken 3 groups: categorical, Y is continuous, that is job satisfaction. The distribution is normal. So we are going to use ANOVA test. And if you use ANOVA test, how you are going to write the hypothesis? Same as t-test. What is that? There is no significant difference between the departments with regard to job satisfaction, will be the null hypothesis. And alternative hypothesis will be there is significant difference between the departments with regard to job satisfaction. On the other hand, X as categorical values, variable, and Y is continuous, but the distribution is not normal. It is non-normal. Then you are going to use Kruskal-Wallis test. Kruskal-Wallis test, you are going to use it if the distribution is non-normal. How you are going to formulate hypothesis? It will be same as how you have done it for ANOVA test or t-test. Then ANOVA table. Before you analyze the ANOVA table, you need to do variance test or Levin test. You have to do it. Now, what is this? Here you are going to see whether data has equal variance or not. To find out that, you are going to do this Levin test or variance test. How we are going to formulate the hypothesis? HO, how we are going to write? Data as equal variance. H1, data as no equal variance. And if what is the p value? It is 0.345. So if null hypothesis is accepted as p value, where is that p? Here. Oh, second part. P value is 0.215, which is more than 0.05. So null hypothesis is accepted. Now, what is null hypothesis? Data as equal variance. Only then you can proceed to calculate ANOVA values. Okay. In case of ANOVA values, how you are going to write the report? The first point will be F test is used to test the significant difference between the departments with regard to job satisfaction. Second point, it can be seen from the table that null hypothesis is accepted as the p-value is more than 0.05 for job satisfaction. That's all. Only 2 points. But before doing ANOVA, we have to do variance test. Okay. I thought let me stop at this stage. Tomorrow, we are going to do what is that? Correlation, regression, mediation analysis, moderation analysis, SEM analysis tomorrow. Is it okay?
Okay, ma'am.
Sir, my presentation is over, sir. There is one question here.
Excuse me, ma'am.
Yes.
Ma'am, I have used the Jamovi software for pilot study questionnaires. Hello,
Mm.
audible, ma'am?
Yeah, yeah.
Yeah, I have used the Jamovi software for the pilot study questions. Is it possible to use for the same Jamovi software for the more respondents? For example, if I take a sample of 500 or 600 respondents, is it
Yeah,
suitable to use the Jamovi software?
yeah. You can use it. Jamovi, we cannot use it for SEM analysis.
Okay.
Otherwise,
Okay,
any
ma'am. Yeah. Tell me, ma'am.
yeah, any number of respondents, not a problem. Jamovi can be used, but SEM
Okay, ma'am.
analysis it
Ma'am,
is
how to
not possible.
identify? Ma'am, how to identify the for which questions which test will be applicable?
Uh, Test, hypothesis test.
Yeah. How to identify which test will be applicable for the which hypothesis and which questions?
No, I told you no. If you have categorical data,
Okay.
chi-square,
Okay.
and x you use demographic variables, and
Okay.
y you have
Hmm.
taken the data on 5 point scale or 7 point scale, so it becomes
Hmm.
continuous data.
Hmm. Hmm.
If
Hmm.
you have such kind of data, then t test, provided
Hmm.
these
Hmm.
study groups are only two:
Okay.
private, public, male, female, top level, lower level, something like that. If you have only two groups, use
Okay,
t
ma'am.
test. If you
Got it,
have
ma'am.
more than two groups, go for
Hmm.
ANOVA.
Okay, ma'am. Thank you.
If
Thank
both
you. And
X
hmm.
also continuous, Y also continuous, then
Hmm.
tomorrow we'll be discussing correlation, regression. That will come.
Yeah, ma'am. It is very useful for me because I'm in the stage of data collection. So it
Okay.
is very useful for me, ma'am. Thank you.
Yeah, one more, ma'am, question from my side is that normally convergent discriminant validity and all, what should be the sample size, ma'am? For Cronbach alpha, we have a sample greater than 30. For convergent validity, discriminant validity and all, initially, is it possible to apply?
I told you, no, based on the number of questions, and one question, 10 respondents. If you have 100 questions, 100 into 10, that many number of samples you should have.
Then
That
it
is
means
only
that,
to do this factor analysis.
yeah. Then for a bigger data only, we can use these convergent and discriminant validity. For
Yeah,
smaller data greater than 30 or initially only Cronbach alpha can be utilized. Am I right, ma'am?
yes. Theory itself tells, no, you should have a huge, large number of items. Only then it becomes easy to reduce it to few meaningful factors.
Yeah, that's right. But for pilot study, we can't collect 500 sample size, no, ma'am.
It can be less also, not a problem.
Yeah.
Thank you. Thank you, sir. Thank you. See you tomorrow.